Welcome to a quick lesson about adding vectors. These are just some things that we need to know, some big picture concepts that we should be aware of when we look to add vectors. Now, the first one is that the basic idea of adding vectors, if I add vector A and vector B, is that I'm actually combining them. So if I have vector A here and vector B, I'm combining them when I add them into a single vector, the resultant. And when I go to combine vectors, we have to make sure of a couple things. First off, they have to be the same units. So I could combine displacement vectors A and B, which would be in meters maybe. And then my answer would also be in meters. Or they could be velocity vectors, meters per second plus meters per second, and then my resultant vector would be meters per second. What I can't do is combine things that are different units, say meters per second squared and meters per second. Those will not add together. They will not combine. Adding vectors is combining them into a single one. Okay, so if we're paying attention to that, we can have three basic situations. Our first one is if we are adding parallel vectors, if they are either in the same direction or opposite directions. So a practical example of that is if you're on a train car, say, and the train is traveling along, even if it's on lousy non-circular wheels, and it's traveling along at 30 meters per second. If I walk toward the front of the car because, I don't know, there's the snack machine up here, and I walk forward in the car at 2 meters per second, well then somebody outside will see what amounts to a combined velocity, and we'll find that velocity by combining velocity 1, the velocity of the train, and my velocity. And so what will happen then is we'll have 30 meters per second to the right and 2 meters per second to the right. Since they're in the same direction, they will add up. And this person, if they could watch me through the walls of the car, would say I was moving 32 meters per second. Well, what if I get the snack and walk back at 2 meters per second? Well, now this 2 meters per second is backwards. Opposite direction means I subtract. So now, if I'm walking backwards against the 30 meters per second, somebody watching from outside would say this vector plus this opposite vector would add up to, combine to a combined speed of 28 meters per second. The train is moving to the right at 30 meters per second, but I'm going against it, so I am actually not moving to the right as quickly as the rest of the train. Okay, our next situation is for adding perpendicular vectors. And these situations do match what we had in the notes. If we wanted to add perpendicular vectors, before we could just add and subtract. But if I take displacements, for example, and I go 3 meters to the east and 4 meters to the north, drawing not to scale, then I can't just say that the combined displacement vector from start to finish is 7 meters. No. But you've seen this before. You know what this is. You know that we would take our x, our total x, and square it, and our total y and square it. Total motion to the right was 3 meters. Total motion up was 4 meters, or to the north, let's say. And then we combine those using the Pythagorean theorem. 3 squared plus 4 squared, that's going to equal 5 squared. And when I take the square root, what we'll find is that my displacement is 5 meters. Now, is that 5 meters east? Is it 5 meters north? No. It is at an angle. And so we would really need to find that angle. And so with a little bit of trig, we could work out that we could use some inverse trig, and this is a kind of separate lesson, and if you need to get help on that, you can. But if I wanted to figure out what this angle is, I could use the inverse tangent. And I would figure out that this is around 53 degrees. Okay, so that's how we combine perpendicular. We can combine perpendicular into a diagonal if we need to. We want to pay attention to direction, and you will occasionally be asked to do, to come up not only with the magnitude, 5 meters, but the direction, the angle. Okay, our last situation is if one or more of the vectors is diagonal. Now before, we've only dealt with left, right, east, west, or up, down, north, south. We've only dealt with stuff that was perpendicular. But if I have a vector that is both right and up, or east and north, not as an answer, but as a beginning point, well, basically, we are going to take that and split it into components. So that if this is, let's say, vector A, we are going to figure out how much A is to the right and how much it's up. You've seen before that we combined perpendicular vectors. Well, we can go in the opposite direction. We can split a diagonal vector into perpendicular vectors. And then that should make it much easier. We can combine this guy with the other x vectors and combine this guy with the other y vectors. And in fact, our next video lesson will be the details on how to do that. But to do this algebraically, rather than, if we don't want to have to draw everything to scale, we can use some trig. We can figure out what these perpendicular components are. We'll look forward to seeing you in the next lesson.